everything we are mentioning here in DFA, but in NFA we may or may not, like whatever is the need, that only we can design. So in NFA we will see later that null moves are also allowed, that can without reading any input symbol, without reading anything, that like from one state to another state we can move, like with only null transition we can move to one to another in NFA, that we will see here. Now this is the definition, formal definition of NFA, that is NFA is also consisting of 5 tuple. Here Q summation Q0 or Q, F and del. For this one, Q is set of all in states and summation is set of all input symbols, that Q is the initial state. Suppose we will be mentioning maybe Q0 as the initial state. F is only one final state. Here it is no longer a set of final state, that we need to remember. The only changing point is F and del. F is here only one final state, and transition function now it is defining as Q into summation, that is for actually for all the NFA. For this NFA, with because we are not considering here null move, it should be Q into summation, it goes to 2 to the power Q. So how we can check? Suppose we have two state Q0 and Q1 and we have to input alphabet. So where it can go with 0, from Q0 it can go to Q0, from 0 with 0 it can go to Q1, it can go to nowhere, that is with 0 it is not going to anywhere, or it is reaching to both Q1 and Q2. That means with this one we can write it as in this way, or we can write it as Q0, or we can give both the transition with Q0, or we can just make this one also with no transition. That means 4 possible moves are there with per state to input. Similarly, if we consider another state and input, then same condition we can get, that is Q1 by 0, Q1 by 1 we can go to Q0, we can go to nowhere, we can go to Q1, or you can go to Q0, Q1. So there are 2 possible moves. Therefore we can consider it as 2 to the power 4 into 4, that is by 8 combination is possible for this one, 2 to the power number of states for per input alphabet. Now this is an example, that is NFA with 0 and 1, that is accepting all the string that is ending with 0. Here we can see this string, it is, and if it is ending with 0, so it can have anything in between in the starting, that is a string can have at least, it should have at least 1 0, other than that it can have 0 0 0 1 0 or 0 0 1 0 anything, but it should always end with 0. So we are not considering this from Q2, we have not given 0 and 1, these things we don't need to bother about, we are only considering where it can go with this input state. Now NFA and DFA equivalence, we can say, because every DFA it behaves like NFA in, like by default every DFA will be NFA, because by DFA from this 2 to the power Q state there is because whenever Q into summation we are going to at least one state, here we are going to Q into summation to at least to the power Q state. So this Q belongs to at least one of these 2 to the power Q states. That means by this we can define it as DFA is by default an NFA, and NFA can be converted to DFA. That means that DFA is by default NFA, we can say, and NFA can be converted to DFA. That's why when two machines are all these are logical machines only, and we can convert from each other, that means they are having the equal power. So in NFA and DFA we can say that DFA are deterministic, that means all the moves we have to mention here. In NFA we don't need to care about the moves, and for every symbolic representation there should be at least one and only transition in DFA. In NFA there can have more than transitions, and similarly like in DFA we have to define like next possible move, that is distinctly set. In NFA it can be anything. In DFA that configurations are not allowed, that is this is not about dead state. Here from Q0 if we write in this way, that is not allowed to if we are not moving anything to any state, like for 0, that configuration, like we are reaching to 0 and we don't have a path for 0, that is not allowed in DFA, but that is allowed in NFA. Epsilon moves are not allowed in DFA, but it is allowed in NFA, that we will see. And in DFA it allows only one move for every single alphabet, that is by one we cannot go to more than one place in DFA, but in NFA we can go to, this is allowed in NFA but not in DFA. Now to convert from NFA to DFA, suppose we have a machine, we can easily convert it. Let us see first one example, then we will come to this one. Suppose this is an NFA, and by this one you can see here the NFA example, because here by 1 it is going to here, by 0 it is going to self loop, it has a self loop as well as it is going to here. Similarly by 1 it is going to itself, that is self loop, and it is going also going to here, that means it is a like self loop kind of thing. That's why 2 by 1 from Q1 by 1 we are going to by 0 we are going to Q1 itself and Q2, that means more than one state we are going, that is not possible in DFA. Now to convert this diagram, what we need to do, that we can see here. First we have to mention here in the state left hand side, we are writing here all the states with its final state symbol and initial state symbol. Suppose here we have 3 states, Q0, Q1 and Q2. Q0 is the initial state and Q2 is the final state. So from Q0, where it will be going by 0 we will mention here, and where it is going by 1 we will mention here. So from this one, first we are considering with Q0. With Q0 it is going to Q0, and from by 1 it is going to Q1. We can see here by 1 it is only going to Q1, so it is Q1. Now sorry, here by this one it is going to Q1. Now from Q1 by 0 it is going to Q0 and Q1, and by 1 it is Q1. For Q2 by 0 it is only going to Q2, and for 1 it is Q0, Q1 and Q2. So these are the transitions we have. Now what we have to consider is, for designing NFA we can take any alphabet from this one, like any state combination from this one, and we can start transition. Suppose we have starting with Q0, so from Q0 let us start with Q0 as this is the initial state. From Q0 where we are moving, Q0 and Q1. From this one we can see that by Q0 we are moving to Q0 by 0 and Q1 this one. So the new state here it is discovered is Q1. So we will write here now Q1. For Q1 where it is going, we have to check now. So for Q1 it is going to by 0 Q0 Q1 and here Q1. So the same thing we will write here as Q0 Q1 and Q1. Now the new Q1 is repeating stated, we already have mentioned it here. Now the new state is Q0 Q1 Q2. So Q1 Q2 will be here, and the strings we can check here. Now we have to, these are now this table is completed, no other like transitions are there which we have not inputted here. So the thing is that now these will be our states. Now which will be initial state? The previous initial state, that is Q0, all the initial, that will be initial state that is containing this Q0, and final state will be those states which is containing Q2. So this diagram is actually not okay for this one. So if we design this diagram, so we will start with Q0, we have one state Q1, another state as Q0 Q1 Q2. So by from Q1 we can go to Q1 by 0, and by 1 we are going to Q1. So from Q1 we are going to Q1 Q2 by 0, and by 1 we are having a self loop of this one. From Q1 Q2 we are going to itself, that is Q1 and Q2. Now if we see, now this is our final state because this is Q2, and if we see for Q0 both the transitions are written here, for this one also both the transitions are written here, for this one also we have both the transition. So by this way we can convert a during this one DFA to NFA to DFA. There is another example. This is also an NFA because by 0 we are coming here as well as here. So if we design this one, so from Q0 we are going to Q0 and Q1 by 0, and by 1 we are going to Q1, and then for Q1 we have no transition actually with 0, and we have a transition for 1, that is Q0 Q1. If we design this one, so by Q0 we have went through Q0 Q1 and Q1. Now for Q1 we have seen here For q1 we don't have a transition, first one, and second one is q0 q1.